The far reaches of our solar system, beyond the familiar orbits of Neptune and the distant outer planets, remain an enigma. Here, in the shadowy expanse of space, lie ancient worlds, silent, cold, and hidden in darkness. Yet, as our scientific tools improve, we are beginning to uncover the secrets of these far-off objects. Among these far-flung bodies, Pluto and Arrokoth, formerly Ultima Thule, stand out as two of the most intriguing, mysterious, and unique objects we've discovered in recent times. Pluto, once relegated to the status of a lonely, frozen rock, has now revealed itself to be a place of surprising complexity. Once thought to be a desolate and barren dwarf planet, Pluto boasts towering icy volcanoes and a dynamic landscape far beyond what we ever imagined. Meanwhile, the even smaller object Arrokoth, a primordial relic in the Kuiper Belt, appears like a flattened snowman, harboring clues about the origins of our solar system. But what lies beneath Pluto's frozen surface? Could life, even in its most basic forms, take hold in this icy world? And how did such a strange object as Arrokoth come into being, shaped by the forces of the cosmos? On this journey, we will explore the most recent discoveries made about Pluto and Arrokoth, two distant and enigmatic worlds at the very edge of the solar system. The turning point in our understanding of Pluto came on July 14, 2015, when NASA's New Horizons spacecraft made its historic flyby of the dwarf planet. The mission shattered all previous assumptions about Pluto, revealing a surprisingly complex and youthful landscape. Gone were the images of a frozen, featureless rock. Instead, Pluto greeted us with a dynamic and active world, full of surprises. One of the most astonishing discoveries was the presence of giant ice volcanoes, known as cryovolcanoes, unlike anything seen anywhere else in our solar system. These icy volcanoes, which spew a slushy mixture of water, methane, and other volatile substances, reveal that Pluto is not a dead world. The New Horizons data revealed that the volcanic activity is not just a relic of the distant past, but may still be occurring today. This unexpected geological activity raises intriguing questions. How could Pluto, so far from the Sun, still be generating enough heat to support such activity? At the heart of Pluto's surprising geology are its cryovolcanoes. These massive ice mountains, like Wright Mons and Pierd Mons, challenge everything we thought we knew about planetary volcanism. These icy volcanoes are not made of molten rock, but are instead composed of water, ice, methane, and other materials. They may not erupt like the fiery volcanoes on Earth, but if they did, they would spew a semi-frozen slurry rather than molten lava. What's even more fascinating is the apparent youth of Pluto's cryovolcanic landscape. The lack of significant impact craters in the area around these volcanoes suggests that they are only a few 100 million years old, or possibly even younger, just a cosmic blink of an eye. Some scientists have even proposed that the region may still be geologically active today. If true, this would mean Pluto is much more dynamic than we ever thought. Despite its small size, only about 2/3 the diameter of our moon, Pluto has managed to retain enough internal heat to fuel this extraordinary volcanic activity. How does it do this? Some researchers believe that Pluto's internal heat comes from radioactive decay deep within its rocky core. Others suggest that antifreeze-like substances, such as ammonia, could be acting as a kind of insulation, helping to maintain a liquid subsurface layer. One of the most exciting, and perhaps surprising possibilities suggested by New Horizons is the presence of a subsurface ocean beneath Pluto's icy crust. It's a concept that challenges our previous understanding of the dwarf planet as a frozen, lifeless world. Yet, the presence of massive tectonic features, such as giant cracks and fissures on Pluto's surface, suggests that there may be a liquid ocean buried deep beneath its icy shell. This theory is based on the idea that, as water freezes, it expands much like a bottle of water left in the freezer. If Pluto has a subsurface ocean, the freezing of that water would exert pressure on the planet's surface, causing it to stretch and crack. The New Horizons team observed that the planet's crust had indeed been stretched over time, providing indirect evidence that liquid water may still exist beneath the surface. But how could liquid water persist in such an inhospitable environment, where surface temperatures hover around -382 degrees Fahrenheit? Some scientists believe that Pluto's internal heat, which may have been retained since its formation, combined with insulating layers like gas hydrates, could explain why the ocean hasn't frozen completely. These gas hydrates, essentially ice mixed with methane and other gases, have very low thermal conductivity, which helps to trap heat and maintain liquid water beneath the surface. The presence of a subsurface ocean on Pluto raises an intriguing question. Could life exist there? While we have no direct evidence of life on Pluto, the very idea that a liquid ocean could persist beneath its icy surface opens up the possibility that the dwarf planet might be more hospitable to life than we once thought. The ocean, if it exists, could harbor the essential ingredients for life, including water, nutrients, and energy sources. Hydrothermal vents on the ocean floor, similar to those on Earth, could provide the necessary energy for microbial life to thrive. While it is highly unlikely that life currently exists on Pluto, especially since New Horizons was not equipped to search for biological signs, the existence of a subsurface ocean certainly increases the likelihood that Pluto could harbor life in some form. Perhaps microbial life, relying on chemical reactions for energy, could find a home in Pluto's hidden ocean, shielded from the harsh cosmic radiation and extreme cold of the surface. Beyond its surface, Pluto also has a tenuous atmosphere made of nitrogen, with traces of methane and other gases. This atmosphere, though thin, surprised scientists during New Horizons flyby, especially when it was illuminated by Pluto's distant sun. The atmosphere has been undergoing changes as Pluto moves along its elliptical orbit, and in recent years, researchers have observed a drop in atmospheric pressure as the planet moves farther from the sun. In fact, scientists have predicted that by the 2030s, Pluto's atmosphere could collapse entirely, turning the dwarf planet into an airless, icy world. However, this process would not be permanent. As Pluto moves closer to the sun in the future, the atmosphere will likely return, only to once again freeze out as it moves farther away. Pluto is not the only object at the edge of the solar system that has captured our attention. Arrokoth, a tiny object in the Kuiper Belt, was visited by New Horizons in 2019, providing humanity with its first close-up view of a primordial body. This object, which resembles a cosmic snowman, is composed of two irregularly shaped lobes that seem to have merged in the distant past. The data collected from Arrokoth has provided scientists with a unique opportunity to study the early solar system and the formation of planetesimals. Arrokoth's reddish hue and smooth surface are characteristic of ultra-red objects, which are rich in organic materials. The surface is covered with methanol ice and complex organic molecules, which provide clues about the chemical processes that occurred in the early solar system. Remarkably, the surface of Arrokoth does not show any evidence of water ice, suggesting that water is either buried beneath a layer of organics or was simply not present during the object's formation. The discoveries made by New Horizons have only scratched the surface of the mysteries that Pluto and Arrokoth hold. While the mission was only able to spend a brief period observing these objects, it provided crucial data that continues to shape our understanding of the outer solar system. The possibility of returning to Pluto with an orbiter or even a lander to study its atmosphere, surface, and subsurface in greater detail is currently under consideration. Such a mission could provide new insights into Pluto's geology, climate, and potential for life. In the meantime, New Horizons continues its journey through the Kuiper Belt, measuring conditions in this distant region and searching for new objects to explore. As our technology improves and new missions are planned, we will continue to push the boundaries of what we know about these distant, mysterious worlds on the edge of our solar system. The exploration of Pluto and Arrokoth has opened a new chapter in our understanding of the outer solar system. These distant worlds, once thought to be static and lifeless, are revealing themselves to be dynamic and complex. Pluto, with its cryovolcanoes, subsurface ocean, and shifting atmosphere, has proven to be a much more active world than anyone could have imagined. Arakoth, a relic of the early solar system, provides valuable clues about the formation of planets and the organic chemistry that may have led to life on Earth. As our exploration continues, the mysteries of Pluto and Arakoth will likely lead to even more groundbreaking discoveries. The ongoing research and future missions to these distant worlds will undoubtedly reshape our understanding of the solar system and the potential for life beyond Earth. The journey is far from over, and the next chapter of discovery is already beginning to take shape.